So the algorithm of converting the CFG to GNF, Greibach normal form, is like this. So algorithm is nothing but a steps. So the first step is the context-free grammar. Whatever the context-free grammar is given, that must be simplified. That must be simplified. Now, simplified grammar means what? It should not have the epsilon productions. It should not have the epsilon production. There is no unit production, should not be there. And there should not be the useless symbol. Means not non-reachable and non-producing. So this two is called as a useless symbol. So these three things should not be there in the grammar, in the production. So that time that production, that grammar is called as a simplified grammar. So what is our first task? Whatever the given problem is, first try to simplify that grammar by using the methods, simplify that grammar. After simplification, we will start the process of converting the CFG into the GNF. Now the second step of the conversion is called as a rename the variables. So whatever the variables we are having in our grammar, the given grammar, we will rename all that variables in the form of the A1, A2, A3, A4 like this. In the form of the A1, A2, A3 like this. So that renaming is very important. That renaming is very important because after that, whatever the productions we are getting after the renaming, we have to follow this rule. We have to follow this rule. So what that rule is saying? The AI less than or equal to AJ. Now what it means? After renaming the variable 1, 2, 3 odd indexes, the left hand side variable indexed, the left hand side variable index must be less than or equal to the first variable which is at the right hand side. So left side variable index must be less than or equal to the first variable which is the right hand side of the production. So that rule we have to follow. If the production is in this format, no problem. But if it is not in this format, then we have to convert that index production into this format. How will convert in this format? With the help of the substitution method. Now already we are knowing that what is the substitution method? Substituting one equation into another. So that is called a substitution method. So with the help of the substitution method, we'll convert in this format all productions. When all productions are in this format, that is a left-hand side index is always less than or equal to the first variable of the right-hand side of production. After that, if there is any left recursion, so we'll just remove that left recursion. Because already we know in a GNF, left recursion will be a problem. So if the productions after this we are getting, so if they contains any left recursion, so we will remove that left recursion. So after removing the left recursion, we'll get the GNF by using the substitution method. So we'll just check whether every production is into the GNF format. If it is not, we'll use substitution method to convert that production into the GNF. So this is the algorithm of conversion of CFG into the GNF. Conversion of CFG into GNF. Now we'll see one example, and with the help of this algorithm, we'll just try to solve that example. So if the example is given is like this, if the productions are given like this, S is produces AA or terminal A variable produces SS or B variable. This is the given example. Now how to solve this example? So now we have to convert this given CFG into the GNF. Now what GNF says? What is the GNF? Greibach normal form. Greibach normal form says that the production the production, suppose a left hand side variable must have terminal, after that the zero or more number of variables. So every production must be in this format. What is the Greibach normal form? Greibach says that every production must have left hand side variable produces terminal, after that more than zero variable. So the production will always start with the terminal, and after the terminal all must be variable. So this is the GNF. So we have to convert these two production into the GNF. First of all, we will check whether these given productions are into the GNF or not. So first we'll check S produces AA. So the first variable is not a terminal. First symbol is not a terminal. So S produces AA is not a GNF, is not in a GNF. S produces A. S produces A. Yes, it is into the GNF. Because what it says, variable produces terminal, alpha is what? 0 or more. If it is a 0 variables, A produces terminal A. So it is into the GNF. So S produces A is in a GNF. A produces SS, again not starting with the terminal. So this production is not into the GNF. A produces B, yes, it is into the GNF. So total we are having the 4 productions, out of which 2 productions are already into the GNF. So we need not to work on that. But other 2 productions, they are not into the GNF. So we have to convert that 2 productions into the GNF. Okay. Now we will start the process, applying the algorithm onto this problem statement. First is the CFG must be in a simplified form. So we'll check whether this grammar given productions are into the simplified format. So what is simplified format? They should not be useless symbol. Useless means what? Non-generating. There are the 2 variables, S variable, A variable. S variable is associated with the terminal. So S is generating. A variable is also associated with the B variable, B terminal. So A is also generating symbol. So both variables, both symbols are generating symbol. Both are reachable. So whether this is reachable means what? So from S is the starting, A variable is, yes, A variable is reachable from S. So there are the only 2 variables. So S starting variable is always reachable. After that, A second variable, S produces A. So A is also reachable. So both are reachable. So there is no useless symbol. Second, remove the epsilon production. So there is no epsilon productions in this grammar. So no need of removing the epsilon production. Third is remove the unit productions. So again, there is no unit production. So we don't have any useless symbol, epsilon production and unit production. So it means what? The given grammar is simplified grammar. The given grammar is simplified grammar. So there is no need of simplification. So now we'll start with the second. Rename the variables as A1, A2, A3, A4 like this. So we'll rewrite the productions by renaming. So S we will rename it as A1. So A1 produces A variable, second variable we will rename it with the A2. So A2 or A. So where S is equal to A1. So A1 produces A2. All right. So now we are having the 2 variables S and A in my productions. So S variable I will rename it as A1 and A variable I will rename it as A2. So this production after rewriting it will look like this. Now this second production, so A is what? Your A2 produces. This is what? Your A1 or B, where A is equal to A2. So A variable I have renamed it as A2. So these 2 productions will now look like this after renaming the variables. Okay.